Hi friends, welcome to my channel. Today we'll see the conclusion part of an liquid clustering. So in previous sessions we have seen the introduction part of liquid clustering. If you have not seen that, please watch the previous videos. Today let's start with how to read the data from a clustered table. You can read a data in a clustered table using a delta lake client which supports the reading and deletion vector. Include these clustering keys in your query filter for the best results. So how will you use a partition by column in a where-class condition? So similar way, if you use a cluster key in your where-class, it will be in a much faster performance. Why? Because like we are partitioning and optimizing the table based on the clustering key which we have provided while you create a table. So if you do a select star from a table where cluster key column name which is equal to some value, so that the performance will be much faster. Next, see how to change the cluster keys. You can change the clustering keys for a table at any point of time by running an alter table. So this is the best advantage of an cluster keys. And if you use a partition by any column in a table, you can't directly alter the table by a new partition key. You have to create a data frame out of the table and you have to rewrite the data based on the new partition, and you have to do a merge schema to overwrite the schema. So here, with the help of cluster keys, right, you can directly do an alter table so that you can use a new key columns for your table. When you change the clustering keys, the subsequent optimize and write operations uses the new clustering approaches for incremental data which is you going to feed the data, but not to which will not re-return the existing data. Whatever the data which has been loaded with the old partition key, that will be that will be remains same in your table. You can turn off the clustering by setting the keys to none. You can also, let's say you have created a table with some keys as a cluster keys, and you want to now you want to remove the cluster keys from your table. You can make the cluster by as a none. So it doesn't rewrite the existing data but prevents the future optimize operations from using cluster keys. So which means that whenever you feed any incremental data into your table, which won't optimize based on the new keys because you have not provided any keys, but the old data, whatever the history data which is available in the table, which is still optimized by the cluster by key whichever you have chosen earlier. Now see how table is clustered. Now let's say you have one table, you want to see whether the table is a clustered table or not, and by which column it has been clustered. You can use the following two commands: describe a table name and describe a detailed table name to get the more information about the table is clustered or not, and it is clustered by which columns. Now we'll see the limitations parts, like what are the limitations of cluster keys. You can only specify the columns with statistics collected for the clustering keys. So the columns which has been statistics collected, and then only that will be you can use that as a clustered keys. By default in Databricks, the first 32 columns in a delta table which has the statistics collected. You can specify up to 4 columns as an clustering keys. So if you have a requirement of a 5 or 6 columns, you have a key columns, then this won't support. You have max 4 columns you can set as an cluster keys. Structure streaming workloads do not support the clustering on write. So let's say you have a streaming application and you want to use an cluster keys, which is not supported. We'll see one real-time example how to achieve the row level concurrency in a delta table. So row level concurrency is the concurrent issue is one of the biggest problem when you have one target table which is written by the multiple source jobs, right? So when multiple jobs trying to write the same single table at the same time, you will end up with a concurrent issue. To how to overcome the simple approach is like you need a 3-step process. One is like you need a liquid partition table and the deletion deletion vector configuration to be set and the row level configuration to be set. So which will achieve the row level concurrency. First we'll see, we already seen how to create a liquid partition table. So create a table and cluster by the key column, so that which is nothing but a liquid partition table. Next you have to do an alter table, whatever the table you have created, and set the property delta dot enable deletion vector which is equal to true, so that you are enabling the deletion vector. Then the third step is like spark.databricks.delta dot row level concurrency preview which is equal to true. So we are setting the row level concurrency. So this will achieve as a table with a row level concurrency. So we will overcome the concurrent issues whatever we are faced earlier with the normal delta tables. I hope this session and this use case will be helpful to you. Please comment in a session if you want to cover or discuss in detail about any of these topics in liquid partitioning. Thanks for watching. Bye.